everyone, welcome back to my channel. And I know I have taken a lot of time to release this next video of a Spark streaming series. So sorry for that. First of all, sorry for that. And I have gone to my hometown and I wanted to spend some time with my family and wanted to spend some time at my village. So I could not upload my video, but from today we are going to again start our Spark streaming series, and we are going to upload video more frequently. So let's start. So let's firstly revise what all content we have done till now. Okay, so let me open our favorite Visual Studio Code and let's try to see. So till now we have covered two things, right? So let me just go to the playlist itself. This is my channel. Cool. Sorry, let me just go to playlist. In Spark streaming series. Where is that? Oh, here it is. Okay, so here we have uploaded 3 video. One is the intro, one is the second one is the session 1. There we talked about 4 things, right? What all things that we have talked. We talked about what is D streams, what is RDD, what is record, and what is batch durations, right? So this was our session 1, which was focused on mainly 4 things, right? So we talked about what is D streams, what is RDD, what is messages, and what is batch durations. And we have also tried to understood multiple basic concept that what is real-time processing, importance of real-time processing with example. I've given my example where I'm currently working. So my use case where I'm working for the Walmart, and in Walmart I am doing the real-time processing. Okay, so I've given the examples there. We talked about what is Spark streaming and the basic very fundamental concept, that is what is batch durations. Okay, then we moved and understand what is the meaning of these streams, RDD, and messages and records. I hope you are able to recall it. If you are not able to record it, I highly recommend to visit the first video, that is this particular video, Spark streaming session 1. Okay, in session 2 what we have done, in session 2 we have look through one very easy example, that is the word count examples, and we have tried to understand how we try to understand the basic concepts of these streams, batch durations, and RDD with that word count example. That is this sessions video 2. Cool. So, and you already know that I'm already writing multiple documentations and multiple articles on each and every video, which I highly recommend to you to visit before watching any video. For as far as my way of learning things, that I actually read the books or I actually read the documentations first, and then only I go through any videos. So once you have some basic understandings by reading, then if you watch some video it will make more sense, right? So that's why I have writing multiple articles. So where you can find my articles, you can just go to this particular video and go to your go to the descriptions of that. You will find the links of link, or you can just go to my LinkedIn channels and you can just go to my profile. Okay, you can go to my profile and just open my newsletters. So my newsletter name is Big Data Design and Architecture. You can just go there and you can find all my articles here, right? I hope everyone is clear where to find my articles. So so let me start. This is about the sessions 2. This is the Spark streaming part 1 video, articles, where I make you understand about the basic concept. This is the sessions 2, right? So you should read the articles, and actually before recording video I am trying to complete the article, then only I am trying to release the articles. I am trying to complete the articles first, and I am trying to release the video next. I hope everyone is clear about that. And so let's start. So what we are going to talk in today's sessions. So in today's sessions we are going to follow these particular articles, not this one, right? These particular articles, and here we will see 2 things. Here we will be in these particular sessions we will be seeing different sources for streaming. This is the first thing that we will be targeting. I'm sorry, And the second thing is, the first thing is different sources of streaming. We will just understand how we can stream data from different sources. Then we will be talking about stateful and stateless transformations. Cool. So these are the two things that we will be targeting in this particular session. Cool. I hope everyone is ready for this, and let's start discussing these 2 points in a very detailed way. Start understanding different sources of streaming. Okay, so this is the article which I have written. I have also explained each and everything. Whatever I am explaining in the video, I have actually written in this documentation or in this article actually. So see, basically for streaming there can be 2 type of sources. The one can be basic source and other can be advanced sources. So okay, so let me open my Visual Studio and let's try to write. First thing that we are targeting in this particular video to understand different sources for streaming, right? So here we can have a basic source and advanced source. What is basic source? So we can read any data from some socket or from some terminal or something like that. So socket is a basic source. We can actually have one file based streaming or folder based streaming. So what does folder based streaming actually means? Like let's suppose I am having one folder. Okay, let's suppose I am having one folder. Let's suppose I am having one folder file streaming, and whenever I will add some file, my streaming applications will consider the new file as the new input. Like I am having 1.txt, again I will add 2.txt, or again I will add 3.txt. So what it will do, it will keep treating the data as the new streaming data. The same way, the same way that let's suppose I am having let's suppose I am having some localhost, right? And some from the socket I am producing data. I am Ankur. I am running the big data. So, right? So, if I keep adding the my words here, it will be treated as a streaming data to me. The same way I can read any folder and I can treat that as a streaming source for me. Okay, so folder, advanced sources can be Kafka, Kinesis, I hope the spelling is correct, or GCP pops up. Okay, so we can have this type of source. So for basic sources we don't need any external libraries, but for advanced sources we might need some external libraries. So if you follow their documentations, the Spark streaming documentations, it is clearly mentioned there. So let's see, this is the basic sources, right? So basic sources can be file streams. So in the file streams, how can read from that file streams? You can just do SSC, that is streaming context.file streams, and pass the location of the folder, right? And that will help you to create the D streams, right? The same way in our word count example, you remember? Let me open the word count example for you. So in word count example, what you were doing? You will firstly creating the Spark sessions, then you will creating a streaming context, and then in this here you were reading from socket text streams, right? SCC.socket text streams, where you have passed localhost and then the port. The same way you can just pass, instead of socket text streams, you can just pass file text streams, and you can just provide the location of the folder. Okay, and you can use that folder to stream your data. Whenever any new file will be added to that folder, that file will be treated as a streaming data. Cool. Okay, So the same way, this is the basic source and the basic source like sockets and the files, and advanced sources like Kafka. So for Kafka, you might require to add some external libraries in your pom.xml file or .sbt files, and you can just install that library, and you can just, if you follow the documentations correctly, you can just open. Let's suppose I'm opening for Kafka. Okay, so in Kafka, you can see it's very easy code, nothing fancy there. It's just like the same way you have your what you call the way you were streaming data from your socket. The same way we can stream data from the Kafka. If you don't understand Kafka for now, not to worry. It's just a very simple messaging queuing systems, nothing fancy, very easy. It's just that if you don't understand Kafka, don't worry. We will cover Kafka in a greater details in the upcoming videos, in the streaming series itself. But for now, just understand that we can actually stream data from Kafka. And what is Kafka? Kafka is just a messaging queue. And if you want to have very simple descriptions of Kafka, what is Kafka, why it is used, I have actually written one article. You can just follow the articles here. Let me just open the article for you. Which article is this? And I will also ping that article in my descriptions. Okay, so you can just look through the articles. Okay, so you have written one articles where I mentioned the basic meaning of Kafka, why it is used, why it became so famous, and the very basic way of flowing data in Kafka, or flowing data from Kafka, and some of the terminology which is very much used in Kafka. Okay, so I hope you are clear now. So there are two sources, basic sources and the advanced sources. Cool. Now we have to understand the second point, stateful and stateless transformations. Okay, so let's start this. Try to understand very important concept of streaming, that is stateless and stateful transformations. Okay, that is the second topic for us. So before starting stateful and stateless transformations, I would like you to understand two important concepts, that is window size, and second one is the sliding interval. Now you will say, Ankur, what is this? So I have given one example in my article itself, and we will try to understand with respect to that. Okay, so let's suppose your batch durations is 5 seconds. Okay, so let's suppose your batch duration is 5 seconds. So what does this mean? It means that in each 5 seconds you will be getting one RDD, right? So let's suppose my batch duration is 10 seconds, and if I define my window size as 10 seconds, it means that I am interested in 2 RDD, right? So 5 means 1 RDD. If my window size is 10 seconds, it means that I am interested in 2 RDD. And if my, sorry, just 1 minute, and if my sliding interval is 5 seconds, what does this means? That after every 5 seconds I will be adding one RDD and I will be removing the older RDD. So what does this mean? So let's suppose one RDD came. Okay, RDD 1 in first 5 seconds, then after some times you received another RDD. Okay, after this is the first 5 seconds. Okay, let me just write it little clearly so it will be easier for you to understand. In next 5 seconds, this is the 0 to 5 seconds. Okay, from next 5 seconds 10 to 15 seconds. Okay, this is the second batch durations. New RDD came. Now you are having RDD 2 also and RDD 1. Perfect. Cool. Now in next batch duration, that is from 15 to 20 seconds, new RDD become, but your sliding interval is also 5 seconds, right? So let me write it first, then we will remove it. Okay, so new RDD will come, RDD 3, RDD 2 and RDD 1. Okay, perfect. But as your sliding interval is 5 seconds, so in each sliding interval, your one RDD will be removed and one will be added. So what will be the remaining RDD for your operations? You will have RDD3 and RDD1. The oldest RDD will be removed. You got this point? And you will be always interested in 2 RDD. So let's suppose I change this to, I'm giving one more example just to be clear. Okay. So let's suppose if my batch duration is 60 seconds. Okay. If my batch duration is 60 seconds, just let me just copy it instead of writing. Let me write it. Batch duration is 60 seconds and my window size is 300 seconds. Okay. So in 60 seconds, I will be having one RDD. In window size 300 seconds, what does this mean? That we are always interested in 5 RDD, right? 1 RDD. We are always interested for our applications, for our operations to perform. We are always interested only in 5 RDD. And let's suppose my sliding interval is 120 seconds. What does this mean? Or 120 seconds, right? It means that 2 RDD will be added, new RDD will be added, and the oldest 2 RDD will be always removed, right? You got this point, right? So you can just follow these articles and you will be able to understand. I've also written the same thing, and you can also look through this particular image. Okay, you can look through this particular image that here this is the original D stream, this is the window D streams. So in time 1, time 2 and time 3, and if we have defined some windows, this is the window, and after some slidings we will be removing one and we will be removing adding something and we will be removing something, right? So you got it. This is little confusing concept, but if you understand it clearly and give some time to understand, you will be able to understand it. It's very simple, nothing very hard there, but I have seen people getting confused. So you have to understand that what is the batch duration. Batch durations means that in each batch durations we will be having one RDD. What does window size means? Window size means the window size is that we are interested in that particular window size only. And what does sliding interval means? So this is, let's suppose this is the one RDD. Okay, this is the one RDD that we have, and this is the size of window. So it will have multiple RDD, right? In one window size, let's suppose I'm having 3 RDD, 1 RDD, 2 RDD and 3 RDD. And if my sliding intervals, I've defined some sliding interval, what does this will happen? After each batch duration, something will be removed and some new RDD will be added. So it's very simple sliding windows concept that you need to understand. And we will understand it when we try to write our code. We will use write some transformations where we will utilize this windows and sliding, and you will understand it more clearly then. Okay. For now, let's move to the stateless transformation. What does stateless transformation actually means? So till now you have written batch streaming code, right? So in batch streaming code, you were only doing operations on single RDD. Right? You are not having that tension of maintaining previous RDD. But in streaming, just think about it. In streaming, you will never have the whole data, right? Some data has came and some data has not came yet, right? So it's like streaming of data. In batch, when you read from some files, you will have each and every data. But in streaming, that is not the case. Currently you are having some data. After sometimes new data will come, right? So it's like you have to maintain the states of data which has came and data which is going to come, right? So that is the fundamental concept, fundamental difference of stateless and stateful transformation. In stateless transformations, what you do, you always perform operations on single RDD. So all your batch transformations will be always stateless, right? But in your streaming use cases, you wanted to apply the single operation, like you wanted to apply group by key, not on the particular group of data, right? You will be also interested in the next sets of data. So there you have to maintain the history, and there the concept of stateful transformations comes. So here we will be applying aggregations more than one RDD, right? Okay, now in the you will ask that how you are going to apply. There are apply the this stateful transformation. I will apply on whole data, or I can have some time windows or something like that. Yeah, you are correct. It's so stateful transformation we can either apply on whole streaming data, like let's suppose our streaming application is going to run for 10 years. So we can actually apply our stateful transformations on 10 years. It's not actually advisable. Nobody will able to do. You will understand that why somebody will not able to apply stateful transformations throughout their data, or if it, the throughout their streaming data, throughout the streaming durations. You will understand the problems with that. And the second way that I can have a stateful transformation on last 30 minutes or last 3 hours or 5 hours or something like that. Okay, so I hope you have got the difference between stateless and stateful transformations. And let's try to write the code instead of talking more about theory. I am not fan of very theory. You can just read theory from here. It's very simple. Let's start writing our code, and let's try to look through our code. Okay, so to understand the streaming stateful transformations, one of the method that you can look through is the update state by key. So you remember we have a word count example. You remember we have written one word count example code. In the word count example, that was very simple code. What we have done, we have read from just let me increase the sound. So we have read from that socket, and then we have applied our operations. So this was the code that we have written. We have read from socket, and then we have applied our transformations, like applying the flat map and just 1 minute. Okay, so we have applied a flat map, then we have applied the words, and then we have applied the reduce by key. So let's suppose in my terminal, if I write something like let me just open the terminal, and if we'll pass something like let me run the code itself. Okay, I will write something like I am Ankur, right? If I write I am Ankur, so what it will do, it will just take I comma 1, M comma 1, Ankur comma 1, right, for one batch durations. And after 20 seconds, if I after 15 seconds, my batch duration time is 15 seconds, whatever new data will come, like let me just say, let's just see, this is I Ankur and 1, and after 13 seconds, let's suppose new data come, Ankur runs the big data, so right, so it will just take the new data, and it will count the frequency of the words in that particular batch durations, right? So here after 20 seconds it will just loop, and let's wait for the result. Okay, you can see that here Ankur is 1, big is 1, data and something like that, right? So after that, let's suppose new data come, the big data, so is for data engineer mainly, right? So you will see that for each batch duration, it actually counting the frequency of words that is happening that particular batch duration. You can see that big has happened 1, data has happened 1, and mainly has happened 1, and the has happened 1. But let's suppose you wanted to calculate the running sums, like from the beginning, how many times Ankur has occurred, from the beginning, how many times data has occurred, and something like that. So what you will do, you instead of, you can't use this, you can't apply this stateless transformation. You have to apply stateful transformations there, and for doing that, we will apply update state by key. And how update state by key works? Update states by key works. I'm just uncommenting it, this code, so I will make you understand. Update state by key works. It needs some one functions, and what does functions need? So you will just, instead of calling reduce by key, you will call it update state by key, and you will just pass one function there. So I have defined one function, update function. So here it required two parameter, that is the new values and the previous state. What does this actually means? It actually means that for the first times, okay, so for the first time if this was the input, so what it will do, so here the new values, okay, and let's suppose you passed this thing, you passed, this was the first letter, and because of that this was the output. Now you passed Ankur runs the big data show. I'm sorry, I'm just, if you pass something like that now, so in the normal code, in normal stateful transformations, state reduced by key, your output should be something like this, right? Because it only consider one batch durations, right? This is the output of reduced by key, right? But in update by key, update state by key, update state by key requires two parameter, right? New values, that is sequence of int, and previous state, right? So let's suppose for the first time this I have written, and the first batch duration, this was the data, right? In update state by key, this will be the thing. In the new value, whenever this will come for the first time, new previous states will be always be null, right? But for the next time, whenever you are writing something like this, what it will do, it will go and look for the previous states. Now the previous states is Ankur 1, right? Now it is Ankur 1, so it will actually update it. So if you look through the code, what I have done, previous state dot get else, right? So get else. So for the first times, this is the option of int. So let me write it here so you will understand a little better. So for the first times, let me copy the code itself here. So see, whenever you have written something like I am Ankur, here it will go and it will look for previous states and get or else. So previous states is 0 because there was nothing. So it will be like newValues.sum, right? So newValue.sum. So I will be 1, Ankur will be 1, am will be 1, right? But when you type Ankur runs the big data show, here in the previous states, when it looks for Ankur, it actually have some values, right? So it will add it. So it will, instead of having these things, this particular output, it will have more output, like Ankur will have 2, right? And it will also have this I1, right? Ankur 1 and am 1. You got it how it is working, right? So it is utilizing the previous state and then it is summing the new value sums, right? So it's very simple. If you just look through these particular things, here I have also given the example. So what it will do, it will actually create one dictionary. It's something like that. It will create something like Ankur, comma 1, comma 1, right? And this, the sum will be 2. So it will produce output like this. So let me just run the code instead of this count. Let me just run running count. Okay, let me change it and run this code. Okay, and then we will, let me just close this terminal itself. I will again run it. Let me run it again. Okay, so for the first time nothing is there, so nothing will come because we have not produced any data from our producer, right? So nothing is there. Let me just type the first thing, I am Ankur. Perfect. So here the output will be same like our reduce by key, right? So let's wait for 15 seconds, right? So let's wait for 15 seconds, right? Now if I type Ankur runs the big data So perfect. Let's see the output. You can see the Ankur is 2 now. It's calculating the running sum because it has the previous state, and where it is actually saving its previous state. You will see that I have defined my checkpointing directory. So if you just see this checkpointing directory, we will talk in a very detailed way what is checkpointing directory. But for now, just understand that in checkpointing directory we can store our states. So in this particular directory, it will actually store these particular informations, and whenever you will be running next batch or next after next batch durations, it will read from that particular locations, right, and it will update it. So if I will write Ankur again, so you will just see that every times it's getting the output, right? So Ankur again, you will see that now Ankur will updated to 3 because it has the previous informations. Just wait for next 15 seconds. You can see Ankur is 3. Cool. So you understand this is the difference between a stateless and a stateful transformations. Once you start writing Spark structure streaming instead of Spark streaming, this is very simple there. It's very simple to write stateful and stateless transformation when you are writing a structure streaming code instead of writing a Spark streaming code. But it's if you understand this particular concept, if you understand UpdateStateByKey, if you understand stateless, if you understand stateful transformations, you will always be in a better positions. I hope you have understood these particular things. If you have any doubt, just read these articles. You will have understood each and everything. I have tried to make you understand, but yeah, this is the little hard concept. I can it takes some time and it will take some practice to do. So just don't follow the video itself, read the documentation, try to write code by yourself, okay? And now I'm stopping this video, and we will meet in the next video, and we will try to understand some more example of stateful transformation like reduce state. So what was the function name? Let me just 1 minute. Reduce by key and window, right? So reduce by key and window, there is something called count by window, right? So there are multiple transformations we will try to understand. So bye for now, and if you are having any doubt, feel free to write in the comment sections and try to discuss in comment section with the fellow members. If I am not able to reply, go through these articles and try to write the code, whatever code that I am writing, try to follow the documentations. This Spark streaming documentations are really good. Try to follow the documentation and try to write the code. If you don't write the code, if you just watch the video, you will never understand, because streaming is a complex topic, right? If you don't write the code, if you just keep watching the video, you will not understand. So I will highly advise you to write the code, read the articles, read the documentations, follow the video, and you are good to go. Okay, I hope you got something from this video. Bye for now. Let's meet in the next video. Thank you.